Before I start this tutorial, I just want to clarify, I'm not weird for making a tentacle tutorial, okay? You're weird for watching one. As long as we have that understanding, I am comfortable proceeding forward. So, yes, the rumors are true. We are making a procedural tentacle in Blender that can go to any shape. We can also, like, trim it. I don't know why I'm going in here being like, oh, it has this parameter, it has that parameter. There's fucking like 30 parameters this thing has. So, if you're ready to delve in with me with a geometry shader nodes tutorial to make a tentacle, stick around. But we do have a sponsor. Don't you fucking click away as well. We do have a sponsor for this tutorial. First, let me talk about them, and then let's make a tentacle. This tutorial is sponsored by Yahaha Studios, which is a user-generated content creation platform where you can download and create your own assets and share in this 3D multiplayer space with other people. You just use templates, move stuff around, and you don't need any coding or server knowledge to get started. For example, I'm going to guide you through making your own experience in the following 6 steps. First of all, we're going to choose the hide and seek template from the create section, so that's the template we're choosing. Next, inside that template, we're going to go to the asset library and pick a component. In this case, we could do the behavior player transformation component card, and we're going to add that card to our assets. Now, the third step is we're going to go back to the asset library, and I'm just going to pick a 3D asset. So pick whatever you want, and we're going to click view in scene, and the chosen asset, whatever you pick, will be added to the map. Okay, now step 4 is you're going to drag your chosen 3D asset, whatever it is you chose, to the spawn point, and this is just to make sure that you can see it immediately when you're play testing the game. Now in the 5th step, we're going to select this 3D asset, and we're going to go to gameplay setup menu, and on the right side, I'm going to click add component to add the behavior player transformation component card we got before to this chosen 3D asset. Now on step 6, I'm going to click the play button on the top right corner, and I'm going to enter playtest mode, and we can try to trigger this model that we put in the scene because we just gave it movement is the point. Okay, so if something like this interests you, you can click the link in the description, or you can use the QR code that's somewhere in the corner to try out Yahaha Studio and make your dream game, again, without any coding knowledge or anything like this. And yeah, thank you for sponsoring Yahaha Studios, and now let's make some tentacles. Okay, we are back. Let's make a procedural tentacle, which actually is, I was going to say it's not as hard as it seems, but it's kind of a mediocre level. It's not advanced, but it's not basic either. Either way, in a fresh Blender scene, go to geometry nodes, delete everything, and add in a cube. Why did we delete the cube? Because deleting the default cube is a rite of passage. And with a new cube, we can make it a geometry nodes object. So, basically, the algorithm that we're going to be using to make this, by the way, is we're going to make a spiral, or you can use a custom curve. With the spiral, we're going to give it thickness, and on that thickness, probably isn't the first time you heard that sentence, on that thickness, we're going to be generating those, like, suckers, those, like, plunger-looking things, and make a material in all this. So that's the algorithm. Starting off with the curve, we can start with a curve spiral. This is, I guess we could do this from the top view. This is going to generate us a spiral. I want to make sure the end radius, or the start radius rather, is 0, so that it goes all the way to the center point. And I think beyond that, I am comfortable. Yes? Yes. Okay, so take this, bring up the resolution. I don't want to really mess with much more of this spiral. You could kind of extend it if you wanted to make a handle, but I'm not going to do that here. That's for the anal people who want to, like, know every detail. Don't worry about it. We're going to take this, we're going to convert it into a mesh. So I'm using a curve to mesh with a circle as the sweeping curve. This is going to give us some thickness. And what I want to do is change this over time, the thickness. So I'm going to set curve radius. The radius is going to be dependent on how far along the curve we are, in other words, the parameter. And now you can see we get something that thins as we go. But we could do even better. What we could do is we could change the radius as we go along it. There's 2 ways to do that. I'm contemplating what the best way would be. I think what we want to do is I'm going to now add, so we have the factor, and we're going to add a second parameter. This is going to be a noise function. So I'm going to take a noise texture. You can see this kind of gives it kind of roughness. I want to bring down the scale so it doesn't look as intense, bring down the detail as well. And what we can do is if we use the spline parameter as the coordinate system for this, and we add a kind of an offset over time, what you're going to notice is now we have a pulsating of our thing. It looks pretty good. If we bring up the scale, it's going to have a bit more detail going on there. So you just want to pick the numbers that suit you. I'm going to slow down time by a factor of 6, and that should look pretty good. Only other thing I'm going to do is I'm going to constrain this noise. Instead of going from 0 to 1, I'm going to say take the 0.3 to 0.7 and send it from 0 to 0.3. What that means is it's going to pulsate, but it's going to give a maximum of 0.3 addition to the thickness. So I just did a lot. Let's explain what was going on. I basically had a function that said make the curve a certain radius, and I said we can add another thing. What we're adding is going to be a noise texture that is going to change along the length of it, right? That's why we use the spline parameter as the coordinate system. Change that over time, so a pulse will go all the way down, and it will look a bit more organic. Again, that's easier to see when we bring up the scale. But this just kind of makes it look a lot more alive, and this is just constraining it so it doesn't look so, you know, it doesn't look weird, okay? That's the point. I'm trying to consider if I want to add more rotations or add a bit more going on. I think I'm okay with this. So now we have a pulsating spiral. Congrats. What we want to do to this is you could kind of like break it up and make it more random, more chaotic, whatever. And maybe a way to do that is, and afterwards we're going to add on the suckers, but maybe a way to do this is you can add a bit of distortion to the curve itself, not the radius, but the position of the curve. So I'm going to offset again with a noise. Maybe we can actually reuse this noise from before. Let's see what that gives us. So I'm taking the noise and I'm subtracting away the 0.5, 0.5, 0.5 vector so it stays centered. Add in a bit of scale to make it less intense. Yeah, that adds a little something. So here's without. It's kind of stationary and the radius is changing. And then with, it has a bit more of a dynamic feel to it. Okay. So I'm happy with this. You know, we can mess with this until the crows come. That's not an expression. We can mess with this until the next SpongeBob sequel comes out, but it's not gonna happen. What I want to do is I want to add suckers onto this. We're going to be doing this in kind of a strange way. Here's the hint. By the way, we should save this. I'm going to call it available. I'm getting ahead of myself. I'm going to call it available on Patreon because that's going to be the case. It's going to be available on Patreon. Link in the description. You get the blend files. We have the thing. A hint for what we're going to do next is I'm going to add an extrude mesh node, and you're going to see it kind of makes it look like, well, first of all, it looks interesting, but it kind of makes it look like calamari or something like this, like it's scaled. If we could do this extrusion, but only twice, so we have 2 lanes of like these extruded things, that could be our suckers. So the hint is we're going to be extruding only on a certain area. To do this, I'm going to bring our resolution of our sweeping circle down to 8. So there's only, it's kind of like we're sweeping an octagon, right? There's only going to be 8 options for extrusion. And what I want to do is I want to capture the attribute of the factor of the spline parameter, right? So what I'm saying is look at the sweeping curve. Tell me what the spline parameter is and only extrude. So we want this to be in this selection. Only extrude if it is greater than or less than some amount. And you can see this makes it so that only some of these are working. Point is, we've reserved our extrusion to just 2 lanes of this as opposed to 8, right? So we're extruding it, and I know what you're thinking doesn't look quite good yet. I know. We're going to fix it. We're going to add a subdivision surface. You can see immediately as we do that, it's going to add this nice smoothing effect. And also, before we continue, I just want to mention, this resolution is also going to be proportional to the number of suckers. because that's how many faces there's going to be going along the length of it. What was I saying? We want to make this look more like suckers, something like that. I want to extrude it by a certain amount, but it shouldn't be like getting this like crazy at the end. So I can actually connect this to the factor, so it gets weaker and weaker and weaker over time. It doesn't like that because we need to do the capture attribute version. Okay, what do we have here? So it's gonna scale all the way down. That looks horrible. That looks horrible. What we can do to fix this is we can, this is a bit of a hack. I'm going to extrude off the normal, which is what this is doing by default. I'm going to vector math. I'm going to scale this by the attribute question mark. Let's see what that gives us. Yes, that might have given us the right thing. That is possible. I think I want to invert this is the issue. So I'm going to subtract 1 minus this. And I'm going to multiply to give it a bit of strength. Show me your strength. No, it totally didn't like that. Oh, you know what? I'm an idiot. I'm an idiot. What I want to do is I want to take the scale and bring it down as we get to the tip. The reason I leave these mistakes in, by the way, is so that if you make it, you can kind of like live through my experience and be like, oh, I'm learning. Or maybe if you didn't make that mistake, you could be like, I hate watching this guy who doesn't know what he's doing. Either way, I want to capture the attribute of the other curve, the spiral curve. That's what I was doing wrong. This should be connected to the offset scale. So it starts off big and then the extrusion gets smaller and smaller and smaller. And I just want to take this. And by the way, this is a cool way you can kind of select for this. But you want to multiply by some factor. And now you can see it's not as crazy as it was before, right? We do something like this. Now let's actually make it look like a sucker. So we extruded without the subdivision. You can tell it's just kind of like these squares. What I want to do is I want to kind of inset and extrude downwards. So to do this, and I saw this in another tutorial, I think it was even a tentacle tutorial, what you want to do is you want to scale these elements, only the top ones. And as you scale, you can imagine this as, well, I guess we can do another extrusion by 0. So I'm going to extrude by 0, only on the top, and then I'm going to scale these elements. So you can kind of think of this as a bevel almost. What this is going to do is it's going to give definition to this. So I want you to imagine, we extruded this, we extrude it again, so now this face has another one exactly on top of it, and this scales it down. Right? We can actually look at the geometry here. So we had an extrusion, we extruded again, and then we scaled these elements, as you can see. And then we subdivided it. This is going to give us a nice clean shape. You take this, you say, what do I want to do? I want to extrude yet again. And I'm selecting the top so we're not extruding the rest of the tentacle. And this goes inwards, like that. And now we have suckers. Who doesn't like that? By the way, instead of multiplying this by some constant for the height, why don't we do a random number? So each one's a bit different. So it can go from maybe 0.1 to 0.3. This way there's a bit of variation. And look at that, we have nice suckers. Again, the scale elements is going to kind of control the fill of this. And this is something, again, we can randomize. So let's do that. Some of these are open, some of them are closed. We can even have them animate. I kind of wish I did that for the original. We'll go from 0.1 to 0.3. Or maybe a bit more so they can be more open. And this gives it a nice random look to it. And remember, all of this pulsates and all this. Another thing we can do to make this look a bit more random, by the way, I know I'm all over the place, is we can add a bit of tilt to the curve. Set curve tilt. This is actually going to do nothing, apparently. Let's think about why it's doing nothing. Set curve tilt. Oh no, it is doing something. I just didn't increase it enough. I'm going to tilt this, which is to say spin the curve over the factor and multiply this. If I do this by a lot, you can see we get like this crazy twisty thing. I'm just going to do it a little, and I'm going to add a bit of offset. So here's what it looks like without. It's all kind of facing upwards, these suckers. And then with, you get a bit of rotation and a bit of variation. I'm trying to think if there's anything else we can do before shading. The circle that we're sweeping relates to the octagon that we're sweeping. We can also shape this. That looks horrible. We want to do scale. We can also shape it so that it's kind of like thinner on one end versus the other. It's up to you if you want to do this. I think I'm going to do that a little, which is going to make our tilt even more effective, because now you can see there's a bit of shape to this thing. So I'm going to add a bit more tilt, a bit of offset, and look at that, we have a nice little tentacle. I want to increase the strength of this, so maybe a bit more distortion. Whoa! And maybe a bit more radius changing, question mark. Remember, if we change the scale, we get a crazier effect. I'm going to add some distortion to this, but not that much, just a little. And what happens if we add detail? It makes this kind of a finer motion. I think, no, that looks horrible. I think all that is pretty good. Okay, so we have a tentacle. It's reacting. Let's give it a material. By the way, very important for this material, I'm going to say, we're going to do subsurface scattering and all this. You want to make sure this is a sealed object. I think it matters. To do that, go to Curve to Mesh and fill the caps. That's going to fill these caps. And we can do an even smoother iteration. Look at that. You don't have to make it this smooth. You can make it less so, and then set shade smooth. Okay, so we have our tentacle. Again, I just want to say before we make this material, this resolution is the number of suckers. You can also have it be like a crazy tentacle. Whoa, I'm so crazy. You can do whatever you want with this. In fact, you could even, as long as you resample, let's use a Bezier segment. We connect this here. And you can see we have a tentacle that we can control the resolution of. It kind of looks horrible. Let's make the endpoint further away. You can do whatever you want, is what I'm saying. You can connect any curve. But let's connect our spiral again. I want to make a material. To do this, I'm going to go to Render tab. I'm going to set up our lighting. Super simple. We're going to do Cycles, GPU, Environment, Texture. I'm just loading up in HDRI because I'm lazy. I'm crazy. And I want to make this transparent. Okay, so basically all of this is our tentacle as a snapshot. You know, take a photo of that, and don't need to do the the tutorial. I'm going to add a set material node at the end of this. This is going to basically be a license to kill. No, a license for us to make a material that actually transfers over. So I'm going to call this tentacle. Notice when I rename it here, it renames it there. What this means is that this material is linked to geometry nodes. So you can see it's actually editing here. We're going to do some subsurface scattering, and you're going to see that's going to make it look fleshy. But first, what I want to do is I want to add color in a custom way, not just making it this color, but I want it to kind of look like it's respecting the geometry. So I'm going to send a attribute over. In fact, if we look at all this like extrude, inset, extrude, yada, 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 what I'm going to do is I'm going to separate. In other words, I'm going to isolate the top of this geometry. What do you think that's going to look like, by the way? So we extruded, we inset, we extruded in. So we have these circles. We get these squares. Yay. If you do this, they'll become circles. These are the squares of the tentacles with the right movement and everything. In other words, this is saying where are we inside the sucker. This is useful. What's it called? A plunger? That thing? Whatever. This is useful because if we can scale this down to 0, which makes it kind of invisible, but if we then merge by distance, we get a series of points. So now each point is representing the center of a sucker. If we do this, we can say, look at the distance, this geometry, look at the distance from these points, right? So again, we have this series of points. Now you can see them a bit better. And I want to say calculate the distance from them on for this mesh. and we can store that information. Store named attribute. I'm going to take the distance, plug it in here. I'm going to call this distance, or you know what? I'm going to call it sucker. This is going to let us create a custom attribute. Make sure you have the same name, whatever you called it. That gives us a signed distance function, if you want to call it that, of this thing, and it animates with it. This is useful. You can already see it's kind of giving us a more realistic color mapping that corresponds with the thing. It's useful because now what we can do is we can say, oh, start with this kind of pinkish at the tip. Make it kind of a more intense over here. Let me bring up the contrast. And then halfway in between, kind of make it this like orangey color. And this is going to let us pick a color in this nice gradient sense. And you think these are weird colors to pick. Just trust me. Connect it to the base color. Bring down the roughness because it's slippery. It's in the water. It's shiny. Right? And then the magic happens when I increase the subsurface. And now you can see all of a sudden we get like pink looking flesh. To make it even better, make this the subsurface color. And now I'm just going to tweak with these a bit. It shouldn't be as intense. Make it a little darker. And all of a sudden we get kind of really realistic looking flesh. But we can do even better. We can do even better. We can add a bit of a noise mapping. So I'm going to, or bump mapping. Normal mapping. I'm going to use a Voronoi texture, bring up the scale so we get a bunch of these dots, and yes, you want to make a custom coordinate system based off this so it moves with the mesh. I know. I'm not going to do it for this tutorial, but it is a thing. Take this, bring down the randomness, which is something you rarely do because it kind of makes this grid thing, but in this case you want it to kind of look scaly and all this. So bring down the randomness, connect this to a bump node, connect that to the normal, and all of a sudden you have these kind of fleshy, scale-looking things. By the way, I'm going to bump up the clear coat so it's a bit shinier, bring down the strength, and look at that. All of that together makes this a very fleshy look. Again, the most important thing is how much subsurface scattering you have here. Another thing we can do, not technically accurate, but you could add a bit of transmission. This is what makes it kind of glassy and fleshy. You add in some. It just makes it look better. It's not technically correct, though. But because this is based on subsurface scattering, if I add in a light source and I make it super bright, you can see the light is kind of like leaking through and it makes it kind of red on this tentacle, which is what makes it fleshy. Either way, we have this. We can go to where we have the curve, add in a trim. Didn't like that. Add in a trim curve. And this, nope. This lets us actually animate the thing. Whoa! Maybe I should do it before I set the radius, so that we get a more custom effect, so that the tip is always, just believe me, right? Here we go. And now you have this nice tentacle effect that's coming out of nowhere. I think that's all I have to say about tentacles. You could go on and on. There's more to it, I'm sure. But there you go. Only other thing I'd like to do, I guess, as a final thing, is I'd like to make my center points a bit wider, a bit brighter, and a bit higher contrast, so you can actually see them. There we go. So that's all I really have to say about tentacles. If you enjoyed this tutorial and you want the blend file, or you just like to support what I do, Patreon is the place to do that. There's a link in the description. Again, I want to thank the sponsor of this video. And yeah, grab the blend file in Patreon. I'm going to be doing more full-length tutorials. I know it's been a while. But yeah, that's my time. See ya.